Alright, so this says consider the circuit shown below, find I1, I2, I3, I4, and I5. This is a mess. Okay, so here are 5 unknowns, you need 5 equations. Okay, well, here's one junction, here's another junction. This is a junction and this is a junction, but the opposite junctions, they would give the same equations. So one junction, two junction, we'll use the junction rule there, and then we need 3 more loops. And so here's a loop, 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 and here's a loop. So there's plenty of equations to be had. Okay. All right. So they've labeled the currents for us. Okay, and so on. All right. Find the power supplied by the voltage sources. Find the power dissipated by the resistors. Oh man. All right. So let's do the junction rules. So the first junction says I1 plus I3 equal to I2. And this junction says I3 and I4 is flowing into the junction and I3 and I5 are flowing out. So that equation is I4 is equal to I3 plus I5. Alright, so there we have 2 equations that involve all the unknowns. Okay, and now we need to find we need 3 more equations. So let's see if we can be smart about it. All right, I'll just do L1, L2, and L3, and let's see where we go with that. You guys with me? All right. L1. Okay, we'll always start off on the left corner and go around. Okay, so this is plus V1 minus I1 R1 minus I2 R2 equal to 0. That's 12 volts minus 4 I1 minus 3 I2 equal to 0. Okay, there's equation 3. Loop 2. Again, we're starting here, going around like that. Okay, so that's plus I1 R1 minus V2 minus I3 R3 equal to 0. I1 4 I1 minus 5 minus 2 I3 equal to 0. There's equation 4. Yep. And then for loop 3. So let's see. Loop 3 plus 5 minus I4 R4 plus V2 and yeah, only 2 elements, so equal to 0. So 5 minus 2 I4. Oh, great. So this one gives us I4 right away, 2.5 amps. Again, and let's see. now if this will help us. So we know I4, so this equation gives us I3 plus I5 is 2.5 amps. What the heck? All right, so here's the deal. See, this involves I1, I2, and I3, I1 and I2, and I1 and I3. So we have three equations and three unknowns. We'll solve for that. We'll get I3, and then from there we'll get I5. Okay? So we have a subset of equations, three equations and three unknowns. Okay? So that's a simpler problem. So let me write that down. I1 plus I3 equal to I2. Okay, so equation 1, 3, and 4. Okay, I1 plus I3 equal to I2. There's equation 1. 4I1 plus 3I2 equal to 12. That's equation 3. And then 4I1 minus 2I3. There's equation 4. All right, so now let's, three equations and three unknowns, let's solve for that. So what we're going to do is, what we'll do is we'll take information from here, I substitute for I3 there. Okay, so we'll take information from 1 and substitute it in 4. And what we're going to do is 1 tells us I3 is equal to I2 minus I1, and we are going to substitute that in 4. So 4I1 minus 2I3, which is I2 minus I1, is equal to 5. Yep.
So R is resistance.
Yep.
B is volts.
Mm-hmm.
I is total power supplied.
I is current.
I is current.
Mm-hmm.
And then how do we go and set these equal I plus I2 equals I3 or however you're doing that? Is it just by looking at the picture and it's supposed to tell?
My friend, you're zoned out. You need to be here 110%. I'm watching you. I'm watching everybody. You're coming in and out every 30 seconds. Ohm's law says I times resistance, current times resistance, that's the voltage across the element. I can't pause and answer that question. Okay. So I'm an older guy, but I'll say this. What kind of engineer do you want to be? You need to learn to listen. You need to learn to be here. This stuff is not easy. If you still want to be a mechanical engineer, you need to change your whole study habits. All right. Okay, so what we are doing is, here is we have three equations and three unknowns, and we are trying to reduce it to two equations and two unknowns by putting information from 1 into 4. What will end up, so we are substituting for I3 in there, and that will reduce this equation to I1 and I2, and this equation is I1 and I2. So we'll have reduced to two equations and two unknowns. Okay, so that's what we're doing. Okay, so we substituted for I3 there. That's that. So this is a 6I1 minus 2I2 equal to 5. So we will call this 4 prime. Okay, how did we get 4 prime? We got 4 prime by doing this, putting information from 1 into 4. And now you see what was the point of doing all of that? You see this is I1 and I2, this is I1 and I2. Now we've reduced it to two equations and two unknowns. All right, you see we had to do all of that work for this single step. You had three unknowns and three equations, and you had to do all that stuff to do that. And now we're still not done. You still have to go there because your instructor is stupid. All he can solve is 5x equal to 15. That's all he can do. So we got to go to that step now. Okay? So let's do that. All right, so now what are our two equations? These are our two equations. And we have to reduce that to single equation. One unknown and one equation. So what we can do is, there are many tricks. So let me rewrite them. Okay. So 4I1 plus 3I2 equal to 12, and 6I1 minus 2I2 equal to 5. All right. And now we have to eliminate one variable, so there's various tricks you can do. So you can multiply this equation by 2, this equation by 3, you'll get 6I2s, and then you can add the two equations and reduce them. Okay, so here's one trick. We'll multiply this by 2, we'll multiply this by 3, and what you get is 8I1 plus 6I2 equal to 24. 18I1 minus 6I2 is equal to 15. Now if you add the two equations, this will cancel, so this is 26I1 equal to 39. All right, so see, it took forever to get from there to there. Okay. And also remember, in our problem we had 5 equations and 5 unknowns, and we recognized that there was a subset of 3 equations and 3 unknowns. Okay. And we did all this. You will learn determinants to solve all this stuff. So essentially what you just saw was, here was a determinant, and the bigger the determinant, the harder it is to evaluate, but there was a 3 by 3 determinant that was being solved. And so this was an easy problem. It had zeros there. Okay, so this problem broke down into a 2 by 2 and a 3 by 3 determinant. Well, not quite a 3 by 3, but there was a 3 by 3, and then there were some non-zero terms there. Okay. Anyway, so let's what happened? Huh?
You keep going.
Oh, keep going. Okay, so there you go. So I1 is 39 by 26. .5 amps, and now we can substitute this information somewhere here and solve for I2. So 4 times 1.5 plus 3 I2 equal to 12. So I2 is equal to, this works out to 12. 4 times, that's 6. 12 minus 6 is 6. 6, so I2 works out to 2 amps. Okay, so finally we're getting someplace. Okay, and now we have I1 and I2. We need to solve for I3. I3 is I2 minus I1. Okay, so I3 is I2 minus I1, which is 0.5 amps. Okay, and then we already have I4. So using this equation, we now solve for I3. Now we can get I5. I5 is I4 minus I3. Okay, so I5 is I4 minus I3. And I4 was 2.5 amps. So 2.5 minus 0.5 equal to 2 amps. Okay, so we have solved this mess of equations. So let me gather all the answers. Okay, so I1 was 1.5 amps. I2 is 2 amps. I3 is 0.5 amps. I4 was 2.5 amps. And I5 was 2 amps. Okay, so that's what solving that circuit meant. Solving this circuit meant. Now that we know this, all the current through each element, we know how bright this thing glows. That was the point. Okay, and now you can also figure out our monthly electric bill. Okay, all right.
Still part
Huh.
B and C. They're easy though. It's just power.
Yeah. All right. Ooh. Okay, so find the power supplied by the voltage sources. Okay, so here, find the power supplied by the voltage source. What we need to do is find the current coming through V2. The power supplied by V2 is V2 times I, and the current flowing through V2 is I5. The current flowing through this thing is I2. Okay, so tell you what, I'll grab this guy. So part B, P1, the power supplied by battery V1 is V1 times the current flowing out of the battery. Okay, and that's equal to 12 volts. So before I do that, so power supplied by any battery is that, and the current flowing out of that is that. So 12 volts divided by what was I2? 2 amps. 24 watts. Okay. Similarly, P2 is V2 I5, and that's 5 volts times 10 watts. Okay, and then part C is, what is part C? Find the power dissipated by the resistors. So each resistor, power dissipated by each resistor is I square Ri. Okay, and we know all the currents, so I'm just going to do one, P1. Oh, okay, because I've already used P1 for the power of the battery. Okay, R1, I1 is what is I1? 1.5 amps. Okay, so I1 square R1 okay, 2.25 times 4, that's 9 watts. Okay, and so on, and you guys can do the rest. Okay, so here's the deal. You guys should do a check. The power dissipated by the resistors so I want you guys to do this check. So this is the power dissipated by resistor 1, 2, 3, 4, and 5. That should equal to what? I'm sorry? That should equal the power supplied by the two batteries. Okay? So that should equal P1 24 plus 10, 34 watts. Did you guys understand that? Okay, let me actually verify this for you guys. Okay, so P1, we've done P1, let's do P2. P2R equal to, help me out, I2 is 2 amps, 2 amps square. What is R2? R2 is 3 ohms. So 412 watts. P3R, power dissipated in there is 0.5 amps square. What is 3? 2 ohms. That's 0.25, 0.5 watts. P4R is, what is P4? 2. That's 6.25 times that 12, 13, no, 12.5, right? And what is P5R? is what? 2. What is R? R5? There's no R5. Alright, so that's it. So now let's figure out P1 R plus P4R. That's equal to 9 watts plus 12 watts, 9 plus 12 plus 0.5 plus 12.5 watts. And that is 24, 25 plus 9, 34 watts as promised. Yeah. So it's a good cross check. So what this tells you is you've done a bunch of algebra, and this tells you that you didn't make a mistake, unless you made 2 canceling mistakes.